Hi guys, in this video I want to take you to one of my recent projects, the Msimbazi River in Tanzania. This river runs right through the heart of Dar es Salaam, Tanzania's largest city and economic capital. And since 2018 this river has been changing very fast. Severe flooding and accelerating erosion are threatening homes, infrastructure and the lives of thousands of people along its banks. This river, quite simply, is out of control. In this video we look at the science behind what's happening. What's causing these changes? How far have they spread? What's already being done? And what could the future look like? We visit the problem areas together with local stakeholders and walk you through our findings on the ground. Our focus in this video is on the upper and middle reaches of the Msimbazi River. My name is Kees Slof and I'm a river engineer from the Netherlands. I've been working on the flooding and sediment problems of the Msimbazi already since 2018. I was part of a team from CDR, NORPLAN and Deltares, and we are commissioned to develop both short-term and long-term solutions to stabilize this river. Let's go take a look. So what is actually happening to this river and why are we seeing all these problems? Well, there are two key developments that have pushed the system out of balance. The first one is rapid urbanization. As the city expands, natural ground is replaced by roads, rooftops and paved surfaces. And so rainfall can no longer soak into the earth. Instead, it runs off almost immediately into the river. This makes flood peaks faster and more severe. And the second is soil erosion. Deforestation, hill slope excavation, unpaved roads and construction sites are all stripping the land bare across the catchment. With nothing to hold the soil in place, enormous amounts of sediment are washing into the river with every rainfall event. So together these two forces, more water, moving faster, carrying more sediment, are overwhelming the river system. Looking back at satellite imagery, we can see that the Msimbazi was relatively stable for many years. But then comes 2018, a tipping point. Almost overnight, the river begins to change. Within just a few years, the channel widens from around 15 meters to over 40 meters, more than doubling in size. Meanders that once shifted slowly began to migrate rapidly, cutting into the surrounding lands. Well, the consequences are obviously devastating. Homes are lost, roads are undermined, bridges are destroyed or left stranded as the river shifts around them. So what the satellite images shows us is not a gradual process. It's a river that crossed a threshold and has not recovered back since. Obviously, the sudden surge of sediment from the upper catchment has set off a dramatic transformation here. The original riverbed, once relatively stable, now lies buried beneath thick deposits of sand. And as the river cuts into the compacted soil along its banks, steep unstable cliffs have begun to form. The changing conditions in the catchment are fueling what I call the geomorphic engine of the Msimbazi, driving the river to erode its banks and widen at an alarming rate. The forces that are pushing that engine into a higher gear are the increased flood power and the sediment overloading. As floods grow larger and more intense, the river demands more space, and it takes that space by eroding outward. And when more sediment enters the river than it can carry, the excess settles on the riverbed. Sandbars form and blocking the flow and pushing water sideways like a battering ram against the banks. The banks collapse, sending more sediment downstream, and the cycle continues. So more water, more sediment, weaker banks, each force amplifies the other and together they are transforming this river. as the river widened and meanders began migrating, a new problem emerged at the bridges. These structures were designed for the old river. They were never built to cope with a channel that had more than doubled in width, and the river began to respond. We can see three things happening. First, backing up. A narrow bridge acts like a small dam, slowing water upstream. Sediment settles and the riverbed rises. Second, downstream erosion. Sediment trapped on one side means that the other side goes hungry. The river compensates by eroding its bed just below the bridge. And third, and most dangerous, meander compression. A migrating meander cannot pass through a fixed bridge opening. It gets squeezed tighter and tighter and can eventually cut around the bridge entirely, breaking through the road above it. All these three processes are visible along the Msimbazi today. The story is the same everywhere. A river that has outgrown its infrastructure. This site tells a sobering story about what happens when a river is fought on its own terms. In just 8 years, erosion has pushed this bank back by nearly 40 meters. As a response, a decision was made to backfill the eroded area with garbage, essentially using waste as a substitute for proper bank material. Well, we understand the desperation behind that decision. But without covering the fill with erosion-resistant material, this is not a solution, it's a delay. When the next major flood comes, much of the waste will simply be picked up by the flow and carried downstream, spreading pollution through the lower reaches of the river and beyond. It's just a stark reminder that fighting the river without understanding it rarely ends well. Our project focuses on three solutions for short and mid-term relief: a meander corridor, bank protection and sand traps. Take the meander corridor. When a migrating meander threatens a structure, the instinct is to fix it in place, build a wall, hold the bank. But fixing one point shifts the problem upstream. The meander finds a new weak spot, you fix that too, and eventually you have built a wall along the entire river. We call this the endless wall. It's neither viable nor sustainable. The alternative is to work with the river, not against it. We define a corridor, a designated envelope of space where the river is allowed to migrate freely, and protect only what lies beyond that boundary. So less concrete, more river, a far more durable solution. The second measure is local bank protection, where erosion poses an unacceptable risk to homes or infrastructure. During our site visits we saw that bamboo and other vegetation is already being used in some places to defend against the currents. Where conditions allow, this is our preferred approach, a nature-based solution that works with the river rather than against it. But where currents run strong and erosion cuts deep, vegetation alone may not be enough. In those locations we recommend gabions, wire mesh containers packed with rock, forming a resilient barrier against the water. Not the most natural solution, but proven and effective, and already in use in parts of the basin. Our third measure, a network of sediment traps along the river. These are designated zones where flow slows and sediment settles, ready for removal. As long as the catchment keeps supplying excess sediment, the traps act as a buffer, intercepting material before it chokes the channel. And the river is already showing us where to place them, natural spots where flow slows and sediment gathers on its own. The captured sediment isn't waste, it's a high quality construction sand, a valuable commodity in a fast growing city like Dar es Salaam, so selling it funds the operation itself. Ecological benefit, economic return, a system that pays for itself. Let's conclude. In this video we've walked you through 5 science-based interventions to stabilize the Msimbazi River. Catch the sediment with sand traps, anchor the banks with vegetation and gabions, define the corridor where the river can meander, and finally for the long term heal the catchment by reducing runoff. A resilient Msimbazi means working with the river's energy, not against it, turning flood hazards into managed self-sustaining corridors. Thank you for watching.
Msimbazi, flowing in peace, from the mountains to the valley.